Alright, so this is transformations. We're actually doing day 1 here on our k value. So, when we look at a k value in an equation, we're going to end up translating it up and down. So just one thing about these words, because they do seem to sound the same, is that transformations is an entire group of actions that could happen, like flipping something over an axis, or moving it up or down, or reflecting it, whatever it happens to be. But translating is one of those subcategories. So translating is when you slide something, and in this case, up or down. So transformations is the main idea, translating is kind of a sub-idea. So, taking a look here at the k value itself, if you have any function, and we're using it in this function notation of f of x, okay? If you have any function, you can in fact have this k value that we add or subtract at the end, which would end up shifting, if it's plus, the equation up, or if it's negative, the equation down. So really you just take whatever the equation is and then tack on this plus k at the end. Okay? So, taking a look at our first example here, this is a parent function of x squared. Parent function we've kind of explored a little, but it just means an equation that has not a whole lot happening to it. So just notice x squared, no adding, no subtracting, just x all by itself. So, if we look at this equation here, and we're talking about shifting it up 2 units, that means that every one of these points that was, for instance, at 0, 0, is going to be shifted up 2, and now it's going to be at 0, 2. Or this point here, it's going to be shifted up 2, and now it's over here. And so if you notice, each time that we end up moving this, we're not moving or changing the x value, we're just changing that height or that y value. So if we think about that, especially in a table idea, that means that every one of these y values, this is the y column here, would add a 2. And again, that's because of up 2, which really means plus 2. So in that case, if I want to change my table to reflect this new graph, I would just add 2 and get 11, or add 2 and get 6, or add 2 and get 3, or 2, and then of course because it's a parabola it's going to go back up again. So that means that our other points are going to be here, here, and here. And so hopefully you can see that as we graph this, it hopefully looks like it was taken from that red equation and shifted up 2. Alright, so when it comes to the actual function itself, rather than the table or the image, we are going to take the original function, so we have f of x, and we are going to add 2 to the function. So if we add 2, our new function is just going to become f of x plus 2. But officially, if you're going to graph it, that means that you're going to be writing x squared plus 2. So it doesn't necessarily change anything that has to do with the equation itself. We add that 2 on the end, and now we have a shifted up equation. The next one is a bit tricky, only because it's hard to visually see, but the same thing is going to happen here. Notice that we have something shifting down 3 units. So as we had over here, when it was up 2 units, we added 2, so down 3 units, we're going to subtract 3. And we're going to subtract 3 to all of the y values. So officially, instead of negative 8, we're going to be at negative 11. Instead of negative 5, we're at negative 8. Negative 2, we're at negative 5. 1, we're at negative 2, and 4, we're at positive 1. The easiest way to talk about something shifting up or down is if you take it 1 point at a time. So, as we did before, shifting down 3 units means that we're going to shift it down to this one, 3 units. This next point shifted down 3, makes it down here. Another piece up here, down 3, units, makes it here. And of course, units is used to talk about 1 square. Alright, and so here we are with our equation. Now, as you look at it graphed entirely, it very much does not look like it was shifted down. Especially if you take into account the distance of a square, it actually looks like it's just been shifted down one square. And that's why you kind of zoom in on, and usually I do it because it's an axis, but if you zoom in on this middle point on the axis, you do realize that it goes down 1, 2, 3 spaces. Alright, so don't let the function fool you when it looks like it's actually shifted to the right, or it's shifted down 1, when in reality, if you look at it, especially with a steep slope, it actually is 3 units down. Alright, so how do we write that in the equation? Well, we take the original equation and we subtract 3. So officially that means the original equation, which is 3x minus 2, and we're going to tack on subtracting 3. Unlike the parent function in the previous one, this one is not a parent function, and so we do have things that might combine together. So negative 2 and negative 3 actually combines together to make 3x minus 5. And that is actually our entire new equation that will graph this blue piece over here instead of the red. New parent function, or well, new function. Alright, so that's the idea, and in your homework assignment you are going to end up having equations that you'll have to rewrite based on shifting down or up. You'll have tables that you may have to rewrite based on shifting down or up, or you may have graphs. So again, just in review, transformations is that large concept of moving equations and flipping them and transforming them, okay, into something new, versus translating is that idea of sliding something up or down, or in the case of the next note, it's left or right. So translating or sliding.